Question 1. In the context of refrigeration system diagnostics, Sister Alvarez is troubleshooting a commercial walk-in freezer at a seafood restaurant. The evaporator coil has visible frost buildup and the box temperature is hovering around 28 degrees despite the set point being 0 degrees. He confirms that the TSV bulb is properly attached and insulated and suction pressure is low. Superheat measures 28 degrees. Which of the following should be his next step? Isolate the issue. A. Check the evaporator fan motor for proper operation and airflow obstruction. B. Just the T6 veto the superheat setting. C. Add refrigerant to the system to raise suction pressure. D. Replace the defrost timer immediately. Answer. Correct answer A. Explanation. Frost buildup and high superheat indicate a lack of refrigerant reaching the evaporator, which may be due to airflow issues such as a failed evaporator fan or blockage. Adjusting the TSV or adding refrigerant without confirming airflow could misdiagnose the issue. OSHA 1910.147 and ASHRAE guidelines emphasize proper diagnostic procedures before replacing components. Overcharging or misadjustment may damage the compressor or worsen efficiency. Question 2. Taking into account the electrical fundamentals of commercial kitchen systems, which of the following best explains why? A 280 V three-phase compressor motor in a walk-in freezer tripped the overload protection after a restart. A. The contactor coil voltage was mismatched to the control circuit. B. The start capacitor failed, causing high inrush current. C. A single-phasing condition caused uneven winding currents. D. The thermostat short cycle, triggering high head pressure. Answer. Correct answer. C. Explanation. Single phasing in three-phase systems leads to uneven current draw, overheating, and tripping of overload protection devices. NEC Article 430 requires protective devices for motors to detect such conditions, while a failed start capacitor is relevant to single-phase motors and control mismatches or short cycling are concerns. They are not primary causes of overload in three-phase systems. Question 3. As demonstrated by Mr. Thompson's work on high-volume ice machine, he notes significant drop in ice production and finds the water inlet valve operating intermittently. What should be his first troubleshooting step? A. Replace the inlet water valve to restore consistent flow. B. Check for scale buildup in the water trough and filters. C. Verify the flow switch is not stuck or malfunctioning. D. Inspect the harvest solenoid for ice release malfunction. Answer. Correct answer. C. Explanation. A malfunctioning or stuck float switch can signal the system to stop the water inlet prematurely, leading to inconsistent production. According to manufacturer service manuals and EPA guidelines for water quality management, verifying sensor inputs comes before component replacement. Ice harvest or scale issues typically affect cycle timing or ice thickness, not inlet valve operation. Question 4. Contrary to popular belief, replacing an air filter in a commercial kitchen's makeup air unit is not always a simple routine. Why must a technician verify static pressure before and after replacement? A. To comply with EPA emissions requirements. B. To determine airflow loss through evaporator fins. C. To ensure fan motor current is not exceeding rated amps. D. To confirm proper airflow and avoid pressurization imbalance. Answer. Correct answer. D. Explanation. Verifying static pressure ensures the filter isn't overly restrictive and helps maintain balanced airflow with the exhaust system. Per ASHRAE Standard 62.1 and IMC 2021, pressurization in kitchens is critical for safety and performance. Ignoring static pressure can cause odor migration, temperature imbalance, or even co-backdrafts from appliances. Question 5. During the process of troubleshooting a display case in a commercial deli, it discovers the temperature fluctuates 10 degrees above and below set point. After confirming there are no refrigerant leaks or airflow issues, what is the most likely cause? A. Improper defrost cycle timing. B. Faulty expansion valve. C. Oversized compressor cycling frequently. D. Loose temperature probe connection. Answer. Correct answer. D. Explanation. A loose or poorly placed temperature sensor can result in erratic readings, causing the control board to cycle inaccurately. ASHRAE Equipment Commissioning Guidelines and NEC 725 for control wiring recommend secure, well-placed sensors for stable control. Defrost timing and expansion valve issues usually cause long-term cooling issues, not rapid fluctuations. Question 6. When analyzing the installation of a water-cooled condenser unit in a commercial kitchen's prep area, technician Mr. Morgan observes high head pressure. The water supply temperature is within range, but the pressure drop across the condenser is below specification. What should he investigate next? Adjust the refrigerant charge to improve subcooling. B. Replace the head pressure control valve. C. Check for scale buildup inside the water lines or heat exchanger. D. Inspect the evaporator for airflow blockages. Answer. Correct answer. C. Explanation. Scale buildup in water-cooled condensers leads to decreased heat transfer and increased head pressure even when water temperatures appear normal. Per ASHRAE HVAC applications and EPA Clean Water Act compliance, regular descaling is essential in commercial kitchens. Adjusting refrigerant without addressing scale can mask the problem and damage the compressor. Question 7. From a practical standpoint, why is it essential for HVACR technicians to follow proper recovery procedures when servicing a failed refrigeration compressor in a restaurant walk-in cooler? A. To comply with NEC arc flash protection guidelines. B. To prevent contamination of the evaporator coil. C. To protect against ozone-depleting refrigerant venting and ensure legal compliance. D. To reduce suction line vibration during removal. Answer. Correct answer. C. Explanation. The Clean Air Act Section 608 EPA mandates recovery and proper disposal of refrigerants to prevent environmental harm. Venting refrigerants is illegal and can result in severe fines. OSHA 1910.120 also emphasizes proper PPE and handling during recovery. Arc flash and vibration concerns are unrelated to refrigerant recovery procedures. Question 8. To illustrate this point, Mr. Singh is performing preventive maintenance on a variable air volume valve system connected to a kitchen's dining area. He finds one zone is underventilated. What should be his diagnostic priority? A. Replace the valve box actuator. B. Check the supply air temperature to that zone. C. Inspect the air filter for that zone. D. Verify the damper position feedback from the controller. Answer. Correct answer. D. Explanation. Valve systems rely on damper positioning for airflow control. If the controller isn't receiving accurate feedback or the actuator isn't responding, the zone will receive inadequate airflow. ASHRAE 90.1 and BAS Building Automation System guidelines require regular damper diagnostics. Filter issues reduce airflow but don't affect damper logic directly. Question 9. Throughout the course of troubleshooting an issue in a reach-in freezer, is Gomez notices the compressor short cycles every 90 seconds. The low-pressure control seems to activate too soon. Which component is most likely causing this? A. High-pressure switch calibration error. B. Suction line restriction or partially plugged filter dryer. C. Excessive charge causing high head pressure. D. Fan relay malfunction in the evaporator unit. Answer. Correct answer. B. Explanation. A restriction in the suction line, especially from a clogged filter dryer, causes low suction pressure, which prematurely trips the low-pressure switch. This results in short cycling and insufficient cooling. Per SA and HVACR diagnostic standards, verifying pressure drops across components is essential before considering electrical faults or charge levels. Question 10. Based on the information gathered from technician Mr. Brooks working on a commercial kitchen's brazed copper lines, which condition necessitates purging with nitrogen during brazing? A. Only when the lines are longer than 15 feet. B. To prevent corrosion due to oxygen exposure. C. When the system contains more than 5 pounds of refrigerant. D. To ensure EPA compliance with Section 608 leak repair thresholds. Answer. Correct answer. B. Explanation. Purging with nitrogen prevents oxidation inside the tubing during brazing, which would otherwise cause scale buildup that clogs SVS and filters. While not directly an EPA violation, Poor brazing practices can lead to system inefficiency and premature failure. This is supported by manufacturer best practices and SMACNA guidelines. Question 11. The most significant aspect of effective leak detection in commercial refrigeration systems is understanding the behavior of refrigerant gases. Technician Isa Daniels is inspecting a reach-in freezer with suspected leakage. The system uses R404 and she notices slight frosting on the suction line near the compressor. What would be the best approach to accurately verify and locate a leak? A. Inject UV dye and inspect the system under a blacklight. B. Use an electronic leak detector while the system is running. C. Pressurize the system with oxygen and use soap bubbles. D. Evacuate the system and listen for hissing near suspected areas. Answer. Correct answer. B. Explanation. Electronic leak detectors are highly sensitive and provide reliable results when used while the system is operating and under pressure. EPA Section 608 prohibits the use of oxygen for pressurizing systems due to explosion risks. UV dye is more suited for longer-term leak monitoring, while hissing may not be detectable with small leaks. ASHRAE 147 also recommends electronic detection for safety and accuracy. Question 12. In response to recurring customer complaints about insufficient airflow near the cook line, technician Istaccato investigates the kitchen's exhaust and makeup air system. The exhaust hood is functional, but smoke occasionally spills into the room. Which underlying issue is most likely the root cause? A. Clogged grease filter in the hood reducing exhaust flow. B. The makeup air unit is undersized or non-operational. C. Excessive duct length causing static pressure drop. D. Malfunctioning damper in the return duct. Answer. Correct answer. B. Explanation. A makeup air unit balances the air being exhausted by the hood. If insufficient air is supplied, negative pressure builds up in the space, disrupting hood capture performance. IMCAN the ASHRAE 154 emphasize proper balance between exhaust and supply to ensure containment of effluent. Duct issues and filters reduce performance, but not as severely as makeup air deficiencies. Question 13. While examining a malfunctioning control board in a reach-in refrigerator, Mr. Hassan finds the board not responding to input signals and display lights are flickering intermittently. What should he check first before replacing the board? A. Wiring diagram compatibility with board version. B. Transformer output voltage to the control board. C. Compressor winding resistance. D. Thermostat setpoint alignment with the board. Answer. Correct answer. B. Explanation. A common reason for unresponsive control boards is low voltage from the transformer due to failure or improper wiring. NEC Article 725 and 430 require control circuits to be properly sized and protected. Replacing the board without verifying power supply could result in unnecessary costs or repeated failure. Question 14. The effectiveness of kitchen HVAC systems often depends on filter maintenance. ISRES observes reduced airflow in a prep area supplied by a ducted unit. The system uses MERV 13 filter due to air quality standards. What should she do to determine if the filters are the cause of airflow loss? A. Compare the amperage draw of the blower motor to nameplate data. B. Conduct a thermal imaging scan of the ductwork for cold spots. C. Measure the pressure drop across the filter section. D. Inspect the VFD controlling the blower fan for faults. Answer. Correct answer. C. Explanation. Measuring pressure drop across filters is the industry standard method for determining filter condition. ASHRAE 52.2 recommends routine monitoring of filter performance using manometers. Blower amperage and VFD diagnostics are secondary checks that come after confirming basic airflow resistance. Question 15. From multiple perspectives, Mr. Leonard is reviewing performance issues in a walk-in freezer. He notes high superheat, normal subcooling, and sporadic compressor noise. The TSV AP is operational. What is the most likely cause of these symptoms? A. Restricted suction line or partially blocked filter dryer. B. Overcharged system with poor airflow. C. Failed crankcase heater causing refrigerant migration. D. Flooded evaporator leading to slugging. Answer. Correct answer A. Explanation. High superheat with normal subcooling typically points to insufficient refrigerant reaching the evaporator, often due to A suction line restriction, EPA and manufacturer service manuals recommend filter dryer inspection as a first step. Overcharge and flooded conditions cause opposite symptoms such as low superheat or high head pressure. Question 16. The primary reason for purging a system with nitrogen during evacuation is to improve evacuation speed. Technician Isa Patel is preparing to evacuate a commercial freezer system that had a major repair. What is the proper role of nitrogen in this process? A. To pressurize the system and force refrigerant from oil. B. To break the vacuum and absorb moisture through chemical reaction. C. To sweep out moisture-laden air during triple evacuation. D. To provide an inert atmosphere for all conditioning. Answer. Correct answer. See explanation. In a triple evacuation, nitrogen is used between vacuum pulls to help remove moisture by displacing it with dry, inert gas. This method is consistent with EPA's Section 608 best practices in industry vacuum protocols. Nitrogen is not reactive, so it doesn't absorb moisture chemically. Pressurization is used for leak testing, not dehydration. Question 17. Examining the consequences of improper defrost cycle management in a commercial freezer. Mr. Riley notes that the unit is accumulating excessive frost on the evaporator and product temperatures are rising. The defrost heater checks out electrically. What else should he investigate? A. Verify the door gaskets for air leakage. B. Replace the time delay relay. C. Check for overcharged refrigerant. D. Increase the refrigerant line insulation thickness. Answer. Correct answer. A. Explanation. Air leaks from damaged door gaskets introduce moisture, increasing frost load and defrost frequency. ASHRAE equipment standards and energy codes emphasize gasket integrity for thermal performance. Time relays and overcharge would affect operation but not directly cause increased frost accumulation. Question 18. When faced with a failed start on a walk-in cooler's condensing unit, technician Mr. Delgado finds the contactor is energized but the compressor hums and trips on overload. What diagnostic test should he prioritize? A. Measure line-to-line voltage at the compressor terminals. B. Check capacitor SR equivalent series resistance. C. Test the compressor windings for continuity and resistance. D. Inspect the low-pressure control switch function. Answer. Correct answer. See explanation. A compressor that hums but doesn't start could have failed windings, especially if resistance is imbalanced or there's an internal short. NEC 430 mandates proper motor diagnostics before restart. Voltage tests and capacitor checks are also important, but winding continuity is the primary diagnostic for this symptom. Question 19. Focusing specifically on temperature control, technician is new and finds an ice cream display case cycling erratically between -5 degrees and +20 degrees. The controller uses remote bulb thermostat. What would be the most likely cause? A. Low refrigerant charge causing capacity swings. B. Thermostat sensing bulb dislodged from the evaporator coil. C. Incorrect defrost termination temperature. D. Shorted fan relay causing coil freeze up. Answer. Correct answer. B. Explanation. A mispositioned sensing bulb provides inaccurate temperature feedback, resulting in erratic cycling. According to manufacturer installation specs and ASHRAE 200 standards, sensing bulbs should be firmly attached in proper locations for accurate readings. Defrost issues or low charge cause more gradual rather than rapid temperature swings. Question 20. The development of proper system charging techniques is essential in commercial kitchen HVACR systems. Mr. Wallace is recharging a walk-in freezer system after repairing a leak. The system requires precise superheat and subcooling. What approach should he use for most accurate charging? Add refrigerant until suction pressure matches design spec. B. Charge by total refrigerant weight listed on the nameplate. C. Use the superheat and subcooling method with pressure temperature charts. D. Charge until the sight glass is clear. Answer. Correct answer. C. Explanation. Charging by superheat and subcooling ensures both evaporator and condenser are operating efficiently. This method is recommended by the EPA, ASHRAE, and OEMs. Sight glass charging or suction pressure are only approximate. Charging by nameplate weight assumes the system is identical to factory specs and has no added lines or components. Question 21. In the absence of effective preventive maintenance, a commercial kitchen's ice machine frequently experiences reduced production during high-demand hours. Technicianista Vega notes that the water curtain is operating correctly, but the evaporator plate shows signs of scale buildup. What is the most appropriate next step? A. Replace the harvest solenoid to improve ice drop timing. B. Increase the freeze cycle length to allow for more buildup. C. Conduct descaling and sanitization procedure per manufacturer guidelines. D. Adjust the float switch height to increase water level. Answer. Correct answer. C. Explanation. Scale buildup impedes heat transfer and prevents efficient ice formation. Manufacturer maintenance manuals and the EPA food equipment standards recommend routine descaling to preserve performance. Changing water levels or solenoids doesn't address the underlying mineral accumulation. Ignoring scale increases energy use and shortens equipment lifespan. Question 22. Throughout the course of investigating a recurring tripping breaker issue on a rooftop makeup A unit, technician Wallace notices moisture accumulation around the control box. Which of the following is the most likely root cause? A. A loose contactor coil pulling excess current. B. Condensation forming due to poor enclosure sealing. C. Overvoltage from utility line variations. D. Faulty fan belt slipping under load. Answer. Correct answer. B. Explanation. Moisture inside control panels often results from poor enclosure sealing or missing gaskets, allowing humid kitchen air to condense. NEC Article 110.27 requires proper protection against moisture in electrical enclosures. While overvoltage and belts can cause issues, water intrusion creates direct risk of shorts and break trips. Question 23. Looking at the data on a walk-in cooler with inconsistent product temperatures, technicianista Lynn observes a clear sight glass but measures low subcooling and erratic suction pressure. What should be the primary diagnostic focus? A. Inspecting the suction accumulator for internal debris. B. Verifying the metering device for partial restriction. C. Cleaning the evaporator coil to restore heat exchange. D. Testing the compressor valves for leakage. Answer. Correct answer. B. Explanation. Low subcooling and unstable suction pressure point to inconsistent refrigerant feed, often due to TXV or capillary tube restriction. According to ASHRAE and OES service protocols, metering device function should be verified before diagnosing the compressor or accumulator. A clean sight glass does not guarantee proper refrigerant flow. Question 24. By evaluating airflow performance in a large commercial kitchen, technicianista Price discovers a strong negative pressure near the cook line and odors infiltrating the dining area. Exhaust and makeup A units appear to be operating. What steps should be taken next? A. Rebalance the makeup A and exhaust system to achieve neutral pressure. B. Replace the air filters on the exhaust fans. C. Clean all ductwork upstream of the hoods. D. Install additional inline booster fans. Answer. Correct answer A. Explanation. Negative pressure pulls unconditioned or contaminated air into the space, affecting safety and comfort. ASHRAE 62.1 and IMP require balanced airflow in kitchens to prevent such issues. Rebalancing ensures the building remains slightly positive or neutral. Adding fans or cleaning ducts is secondary to airflow balancing. Question 25. During the process of installing a new condensing unit for a region cooler, Nguyen is preparing to connect the liquid and suction lines. What must she do before brazing to protect the internal surfaces of the tubing? A. Flush the lines with refrigerant to remove residual moisture. B. Install inline filters to catch oxidation flakes. C. Purge nitrogen through the lines during brazing. D. Apply flux to both copper ends before heating. Answer. Correct answer. C. Explanation. Purging with nitrogen during brazing prevents oxidation, which creates scale inside copper tubing. Scale can restrict SVS or clog filtered wires. This is a best practice process, ASHRAE installation standards and EPA section 608 technician guidelines. Flux is not used in HVACR copper brazing applications. Question 26. under the assumption that a high-efficiency evaporator fan motor is continuously running in. A walk-in cooler technician Sloan is tasked with improving energy efficiency, what is a valid method of reducing energy consumption while maintaining performance. Add an evaporator pressure regulator to reduce compressor load. B. Convert the fan motor to an ECM electronically commutated motor. C. Install a larger defrost heater for shorter cycles. D. Lower the defrost frequency to once daily. Answer. Correct answer. B. Explanation. ECMs provide variable speed and greater energy efficiency compared to shaded pole or PSC motors. DOE regulations and ASHRAE 90.1 promote ECM upgrades in commercial refrigeration for energy conservation. Pressure regulators affect compressor performance but don't reduce fan energy use. Question 27. One might argue that ice buildup on an evaporator coil is always due to low refrigerant. However, technician Alvarez notices consistent frosting on the evaporator of a sandwich prep table, but pressures and charge appear normal. What is the most likely culprit? A. Overcharged refrigerant causing coil freeze. B. Low ambient temperature near the evaporator. C. Faulty defrost timer or incomplete defrost cycle. D. Incorrect metering device setting. Answer. Correct answer. C. Explanation. Ice buildup with normal charge and pressures indicates a defrost issue. If heaters or timers fail, frost accumulates and restricts airflow, reducing cooling. OSHA and food safety regulations also require defrost systems to prevent bacterial growth. Overcharge and ambient temps affect pressures, not direct frosting patterns. Question 20. The foundation of motor control in HVACR systems involves understanding relay logic. Mr. Bruno's troubleshooting a control circuit where the condenser fan motor won't start, but the compressor runs normally. What should he test first? A. Verify the run capacitor of the fan motor. B. Inspect the defrost termination sensor. C. Measure voltage across the fan relay contacts. D. Check pressure switch settings. Answer. Correct answer. C. Explanation. Fan motor circuits are often controlled by relays. If the compressor is running but the fan isn't, the fan relay may not be energizing the motor. NEC 430 and Control System Diagnostics recommend testing relay output voltage before checking motor components or sensors. Question 29. As a result of a high head pressure alarm on a rooftop refrigeration unit, technician Kim checks condenser coil cleanliness and fan operation, both of which are normal. Ambient temperature is also within range. What else could cause persistent high head pressure? A. Undersized compressor for the load. B. System overcharge or non-condensables trapped in the condenser. C. Undersized suction line diameter. D. Clogged liquid line filter dryer. Answer. Correct answer. B. Explanation. Excess refrigerant or non-condensables like air increase head pressure and reduce condenser efficiency. This is a common post-service issue when systems aren't properly evacuated. ASHRAE guidelines and EPA Section 608 require full evacuation and proper charging procedures to prevent such problems. Question 30. To determine whether a Reach-in refrigerator is operating efficiently, technician Sanders measures 12 degf superheat and 5 degf subcooling. The ambient temp is 75 degf and box temp is 36 degf. What does this suggest about the system? A. The TSV is overfeeding the evaporator. B. The refrigerant charge is likely too low. C. The system is running with high head pressure. D. The suction line is restricted near the compressor. Answer. Correct answer. B. Explanation. Low subcooling and high superheat typically indicate low refrigerant charge. According to manufacturer charging procedures and ASHRAE guidelines, a properly charged system would have more balanced superheat to cool in. Overfeeding causes low superheat. Restrictions affect pressure patterns differently.